Hello and welcome. My name is Vishwanath M. In this video, let us try to learn and understand the concept of singly circular linked list. If you are following the VTU syllabus, this is program number 9 of Data Structures Laboratory. So in this program, the ask is we are expected to create a singly or single circular linked list and use that in order to evaluate and add polynomials. So this is the program statement or the ask in the program question. So as usual, let us have a very brief understanding of what the SCLL means and then jump on to the program. This program, that is program number 9, you would find different versions of the program, and normally they will all be more difficult and more tricky and less understandable than the version that we have used here. So I have created this code or this version of the program specifically to make the understanding easy and to enable the readers to learn and write the program as well as execute it. So having said that, let us now jump to the concept of SCLL. So we already know what linked list is. We already know what single linked list as well. We know the concept of circular, but not in linked list. We have in one of the other videos we have learned the concept of circular queue. So it is like combining both of them and understanding the concept here. So single linked list is a linked list data structure which has only single link, or it is just one link. And circular, as you could imagine or as you would guess, means that the link is made to point to itself. So that is the basic understanding of SCLL. So in case of a single node, this is how it looks. And another important concept in SCLL is that we have something called as head node. You could even call it the start node, but I am specifically calling it head because this is different from other programs in a way that the head node here, what we are referring to as head node, is this node doesn't really have data. So head node is like you could consider as an additional node, and the first node after the head node will start having the data that you would enter. So that is a prerequisite to know before we dive into the program. So anyway, but the concept of single circular linked list is evident in the image here. So the last node will be the link or the pointer or the reference of the last node is made to point to the head node, or what we just understood as the head of the linked list. So all the other nodes will have data. Since we are dealing with polynomials, this is the structure of the node that we are going to create. So let us understand it parallelly. We have three header files here: stdio for input output, stdlib because we are using malloc function, and math.h because this is a polynomial function and we have the concept of exponent or power. So that is included in the header file math.h. We already know what struct node or structures mean. Again, just revisiting and revising. Structure or struct is used to create user defined data type. So this node is like a user defined data type, and all of these data elements and this link is combined or is consolidated to form one data type known as node. So that is the meaning of structures or struct node. It is already explained in other videos. You could particularly visit program number 10, that is binary search tree, to understand the meaning of structures in much more detail. So anyway, in this program, since we are dealing with polynomials, each polynomial term, so all these is polynomials. So if this is considered as a polynomial, each is called a term, or each could be called as a node. So each node will have coefficient. So you could just see this box representation and the example given right below it. Coefficient, x exponent. So we are dealing with polynomials which have x, y and z variables, and we already know that it is x, y and z. So the exponent means what is the power of the each variable, that is x, y and z. So that is considered, or that is stored in x exponent, y exponent, z exponent, and we will understand why this additional variable called flag is used. That really is not required to represent a polynomial, but it is used in the program for a different purpose. We'll understand why. And obviously, since we are dealing with linked list, that too in particular single linked list, we have one link or one reference. So I hope I have made struct node understandable. Moving on, we know why we use type def. Type def is used to create a nickname for struct node star. So struct node star can simply be called as node further. So that is the meaning of type def. Okay. The functions in the program are as much as possible or wherever possible. I have tried to retain the order and retain the pattern from as you would see in other programs, so that it would be easy to learn and understand. But anyway, this program number 9 is a little unique because we are dealing with single circular linked list. Okay, node create, as you would understand, is used to create a node. So node p is a temporary pointer we create, and we use malloc function, and malloc will have the size of this struct node, that is evident here. And we have been dealing with this condition. If p is equals to 0, that means there is not sufficient memory in the system. This will never normally happen. If this happens, there is something wrong with your computer, and probably you could restart it or ask a different system. So this is not going to happen, but this is a check we need to do for precautionary purpose. So after it is allocated, so all we are doing in the node create function is we are allocating the space required for a node, and we are returning the pointer. So we have understood create function. So after a node is created, so this is like creating an individual node. You might go back to the train image where we had multiple compartments, but train image doesn't make any sense here because we never attach the last node to the last compartment to the first compartment. But anyway, the concept of link would remain the same. Alright, so as we create each individual nodes in create function, we need to attach them to the linked list, and for attachment purpose we use this function called node attach. So node attach has a parameter list inside. So this is just coming from the node structure. So int coefficient, int x exponent, y exponent, z exponent, and node head. So node head is the pointer to the header node in the linked list, or header node in the circular linked list. So node attach is used to attach a node to a circular linked list. In other words, so how are we referring to a circular linked list? Each circular linked list will have its own header node. So if this is one circular linked list, if there was another circular linked list, it will have a different header node. So you will see further in the program that we create two polynomials. So each polynomial will have its own header node. So p1 will have h1, and p2 will have h2, and maybe result will have h3. So that is a good background to have. So that is why we need to pass the head, or we need to pass the header node to the attach function. So in the attach function we use two variables called temp and current. We will understand why it is so. So when we are attaching the node, we first have to create the node. So this create function is called within the attach function temp create, and temp of after the after the node is created, we have the space required. So that space is accessible by this pointer called temp, and since we know the values of coefficient, x exponent, y exponent, and z exponent, we can simply initialize that to the space that we have just been allocated. Temp of coefficient is equals to coefficient, temp of x exponent is equals to x exponent. The same goes with others. Temp of flag, so always initialize flag to 0. We will see why we need this variable called flag, but always initialize that to 0. Okay, so now we have created a temporary node. So temporary node is just the independent node, keeping the same convention we have followed in other videos. So this temporary node is like a independent node or an unlinked node. So we have to link it to the header file, or we have to link it to the header node. So as I already said, in the circular linked list, the header node, which is just like an additional or auxiliary node, it doesn't have data. So this will be the first node. So how do we do that? Current is equals to head of link. So we create this, we are using this pointer called current, and that is pointing to head of link. So head of link will, so this will be cur, and while current of link is not equals to head. So what this means is, suppose if there was a if there is already a linked list created, then we will have to go to the end of the linked list and then add the new node. But in the initial scenario, when we are adding the first node, anyway, a current of link, the first node, this condition will be checked, and if that is not, if for all the other cases, that is when we have multiple nodes in the circular single linked list, this increment operation will take place. So if that is not the case, or like after the increment operation has taken place, we come to the last node, or in the first case it will be the first node itself, and basically we are linking the current of link to the temporary node that we just created. Current of link is equals to temp, and temp of link is equals to head. So what does this signify? So this whatever we are adding at the end, it has to be connected back to the header node. So that is done here. Temp of link is equals to head, and always we return the head node, or whatever is the head node, because as I said, each SCLL or each circular linked list is referenced by the header node. So we always return the header node. So we have understood node attach function. Moving on, we have a function called node read poly or read polynomial. So this is the function where we accept the values for the polynomials. That is why it is appropriately named as read poly. And as I said, to refer to any structure or to refer to any SCLL, we need the head. So it is in the parameter list as expected. So we create these variables or values: x exponent, y exponent, z exponent, and coefficient. I is for iterary purpose, n is for number of nodes. So read poly is where we call the attach function. Attach function will in turn call create function. So read poly function will call attach function will call create function, and ultimately we are creating a singly circular linked list. So enter the number of terms, we accept that in the value called n, and we run a for loop. I is equals to 1, I smaller than, and I plus plus. So every time for each term, so these each of them is a term, or each of them is a node. So for each term we will have to ask the user to enter the coefficient, x exponent, y exponent, and z exponent. So that is what we are doing here, and every time the user has entered the values, we attach that to the header node. Head is equals to attach of, we just pass what we have just accepted as an input from the user, and we pass that with reference to the head. So pay attention to the function prototype. The function prototype has a parameter list. It has node head here, and the same node head is passed to the attach function. We know why it is passed, because we refer linked list by the head. And as I already explained, for the other function, we return head for the reference function, for reference purposes. So we have understood node read poly. So in summary, read poly is where we accept the values for coefficient, x exponent, y exponent, z exponent, and we then call attach function. Attach function in turn calls create function. So make sure that you are writing the program in the same order, because for any function that has to be called, it has to be first defined. So if you are writing it in reverse order, you will probably see an error, but that error would give you the clue that you have to just restructure. So suppose while typing the program, you have typed attach first and create next. While you execute the program, you will see an error. So you could come back and cut and paste to the appropriate location. So always remember, wherever you are calling a function, so you are calling this function called create. So remember that, or have a checkpoint to yourself that create has to be typed before, or it has to be defined before this function, wherever it is, whichever is the calling function. This is the calling function, this is the called function. So these are all basics of C programming. So we have understood read poly now, where we accept the input and create the polynomial. Next, let us understand this function called display. Display, as the name signifies, is used to display the polynomial. So again, as this convention remains throughout the program, to refer to the polynomial, we always use the head. So head is normally passed from the main function. Void display. So we create this temporary variable called temp, and as I said, if it is just a single node, if head of link is equals to head, so this is like the consider this as the header node, right? Suppose nothing existed, so if only a header node existed, head of link will be pointing to head itself. That means there is no polynomial, so we just print the message polynomial doesn't exist and type return. If that is not the case, we move to the first node, temp is equals to head of link, so head of link will be just the first node, and we start the while loop because we are interested to print only the data nodes and not the header node. While temp is not equals to head, so while temp is not equals to head, printf. So the way to print the polynomial, you can take clues from so basically when you are executing this program, make sure that you are writing the polynomial on the sheet of paper that you are writing the write up, and make sure that you have that in reference and type the program, or write it somewhere in the at the end of the sheet or in the rough side of the sheet, and then type the program appropriately, or write the program first appropriately. So how do we demonstrate, or how do we represent the powers? So first we need to print the coefficient, so coefficient is printed %d, and the first variable will be x, so we print x. So this upper arrow indicates the power, so because we don't really have the ability to make it as a subscript or superscript here within C program, we use this symbol upper arrow mark to indicate that it is a power. So upper arrow mark %d, %d will be x exponent, that is x exponent. The same goes with y and z. So I hope I have made this line of code to make sense. So writing this is easy if you have understood this notation. So since we are displaying it here, we have after we display each node, we have to move forward. We know how to move forward in the linked list. Temp is equals to temp of link. So this is, so assume that this is the first temp. Next we move here. How do we do that? We move via the link. So temp is equals to temp of link. So what does this condition mean here? If temp is not equals to head, so when will the temp be not, when will the temp be head? That is when we have reached at the end of the linked list or end of the polynomial. So normally we don't have, so between two polynomials, or between two terms, this is first term, second term, you will have to have a symbol, normally it will be plus. So how we could understand this is each of them so consider this sign for the coefficient, each of them will be its own term, and within the terms you can have a plus. Anyway, you know that so again this program is completely based on mathematics, so at least the basic understanding of polynomials is required. So even if I had put a plus here and consider the whole thing as one term, plus into minus would be minus. So I have not written a plus here, but while in the output you will see that each of them is considered as a separate term and a plus will be inserted in between. So I hope I have convinced that having a plus in between doesn't really make a difference to the polynomial. So what this means, if temp is not equals to head, as long as it is not the last node, we have to print a plus in between to indicate the difference between the nodes. So that is the meaning of this line of code. We have understood the display function right now. So we are now left with the two most important functions of this program, that is evaluate and addition. So before we jump to the program or typing the code for evaluate, let me take some time to explain what evaluation means. I hope all the readers know what a polynomial evaluation means. So basically we have a polynomial like this. So this is the polynomial that is given for the consideration. We have to consider this and do the evaluation. So if in the examination you are given a different polynomial, no big deal, you could still input that polynomial and do the evaluation. So what is evaluation? We take the values of x, y and z. So x, y and z, if we know the values of x, y and z, we can do the evaluation. So for simplicity purpose, we are considering the value of 1, 1, 1 for x, y and z. Why do I do that? Suppose had I considered different values for x, y, z, let's say I have taken the value of y to be 2, then the calculation will be difficult for us to verify. You can still do it, but for demonstration you could simply consider 1, because 1 power any number is 1, 1 power 5 is also 1, 1 power 0 is also 1, 1 power any number is 1. So for I would recommend the readers to take xyz value to be 1, or if a different value is asked, so make sure that you are doing it on paper using a calculator. So how do you do that? So I have put dots between the elements because dot signifies multiplication. I hope all the readers know that. So 6 into 1 square into 1 square into 1 minus. So that is what happens here. So 6 into this whole thing will be 1. So 6 into 1 is 6 minus the second term. So since we don't have the value of x here, so wherever the x is not a symbol is not present, that means its power is 0. So I have not represented it here, but you will see in the output that it will be demonstrated, it will be shown as 0, because how does the computer understand that x is the value of x is the coefficient of x is 0, you have to enter it as 0. So but here because we are doing polynomial evaluation and addition on paper from a long time, so I have skipped that step here. So whatever is there here, I have taken the value of x, y, z and did the evaluation. So fast forward, all the values for x, y and z are substituted. So this is what we get after simplification: 6 minus 4 plus 3 plus 2 minus 2. If you do this sum, the result of the evaluation will be 5. Anyway, we will verify this while we run the output. So why I explain this now is it is important for the users or the readers to know what evaluation means before they type the code for evaluation. So now let us get into evaluation function. Int x, y, z comma value is equals to 0. Value is what the final result will be. So initially it will be 0, and we are creating a temporary variable called poly. Whichever is the header node pass, we can do the evaluation. So we will just use this temporary variable called poly, and so the only input required is what is the value of x, y, z. So we ask the value of x, y, z and take the input for x, y and z respectively. And as I said, since this is a singly circular linked list, the header node will not have any value. We will have to move to the first node. How do we move? This is how we move. Poly is equals to head of link, and after this step is done, from the first node we just go till the end of the list or end of the circular linked list. So every time we move forward, so this is what we are doing. So here is where you will use the power function, because here on paper we can do it mathematical, or using calculator we could do it, but on a C program you would have to use this function called power, and power is there in the math.h header file. So value was initialized to 0. Value is equals to value plus, because if you do the evaluation, so here you start from here. Poly of coefficient will be 6. Star indicates into. I have represented that as dot here. Coefficient into power of x comma poly x exponent. So what is the value of x? Value of x is 1 here. What is the value of exponent? Exponent will be 2. So power of 1 comma 2, that means 1 to the power of 2. That is the meaning of power comma so whatever this is inside the power function. Power, let's take this as a and this b. Power of a comma b means a to the power of b. So here 1 to the power of 2, and the same goes with x, y and z. So after we are done with the first term, we have to move forward. How do we move forward? Poly is equals to poly of link. I hope all the readers are already aware of this technique of moving ahead in the linked list. So every time, so after the first term is evaluated, that will be stored in value, because initially value will be 0, but after we move forward, we have the value of 6, and then we take the next node into consideration and next add that to the value. So that is what happens in this while loop. I hope understanding this was not a challenge, because we have understood this conceptually first and then understood the code. After the value is evaluated, we will just print the evaluation result and use this variable called value. So whatever we have done on paper here, that would be evaluated and that will be displayed in this function called void evaluate. Okay, we are now left with the last function, of course, other than the main function. Poly add or poly addition is again, this is where it gets a little tricky. Other programs that you would find probably will make it complex and difficult to understand. but if you pay close attention to how the explanation goes, understanding this is actually easy. So before, as usual, before we go to the code, let me explain it on paper. This is pure mathematics, no computer science or no C programming here. So I hope this is easy to understand. So what does polynomial addition means? You have two polynomials, polynomial 1 and polynomial 2. So again, if even in the lab exam, you might probably have to do it on paper, and that is on your write-up paper, and then only or maybe you could, if the examiner asks how you are getting an output, this is how you would normally write it on paper and show that this is what is happening in the background. So polynomial addition, let's consider two polynomials P1 and P2, and P1 will be a polynomial, P2 will be a polynomial. So the basics of polynomial addition, so this is what we would have learnt in school. So a quick recap or revision: you could add two polynomials only if the exponent of each variable, that is x, y and z, only if the exponent of each variable is the same, only then you could add the coefficient. I repeat, so this is literally coming from school. You could, if you are able to remember and recap, well and good. So two terms in two polynomials can be added only if and only if the exponent of each variable x, y and z, only if they are equal, only then a polynomial addition can be possible or can be done. When we say polynomial addition, all we are doing is we are adding the coefficient 2 plus 3, we are adding as 5. That is, we are able to do it because the exponent of x, y and z is equal. So that is the heart of this logic. So if you have understood this logic, you will see the same in the program as well. So that is why I always urge or insist that understanding the concept better will enable you to write program efficiently and without memorization. So again, as I just mentioned, if two terms are not the same, for example, you cannot add 2xyz square with xyz or 3x. So that is the inference, or that is the meaning. Going one step ahead, when the exponent or the exponent of each variable x, y, z is equal, we call those terms as like terms. So probably you are getting the memories from school. The terms which have the same exponent values are called like terms, and only like terms can be added. Unlike terms cannot be added. So 2xyz square and xyz are unlike terms because the exponents are not equal, and hence they cannot be added. So that is the background required for addition. So wherever you find, so how do we do addition in the logic here? So let me explain the logic and simultaneously or parallelly explain the code here. So we consider each node. In the polynomial, and we compare it with each node in P2. So have this have an eye on this, or having understood this, let us now jump to the program, and I will again come back to this and explain the logic as we understand the code there. So note polyadd requires two polynomials, and I already explained that polynomials are referred by header nodes. So P1 will have header node H1, P2 will have header node H2, result will have header node H3. Okay, and P1 and P2 are temporary variables. P1 will refer to H1 and P2 will refer to H2, and we are declaring some integers here, x1, y1, z1, coefficient 1, and the same with x2, y2, z2 and coefficient 2, and coefficient res or coefficient result will be the result in the coefficient in the result polynomial. So these are the integer declarations we need to do, and now we are starting we are trying to understand the logic of addition. P1 is equals to H1 of link. So I said header link is like an additional node. So come to the first node. How do we come to the first node? P1 is equals to H1 of link. So here the H1 of link will be this. So assume that the header node is somewhere here. That is not even represented because on maths on paper we don't really bother about header node and stuff. P1 is equals to H1 of link. So this is the first node. So we consider the first node, and so that is why you, as I said, this is a program that I came up or that I wrote to make the program really easy and understandable. So I have used variables which give meaning. So we are considering the first node, and so initially after we have considered initially have it as 0. but we will of course make it as 1 at a later stage. So have this variable called int considered as 0 inside the while loop. After we have considered that, whatever is the exponent 1, 1, 2 in this case. So keep an eye on this polynomial and then understand the code here. So the exponent x power 1, y power 1 and z power 2. So that is stored in the variables x1, y1 and z1 here. So what is the value of x1, y1, z1? It is 1, 1, 2. Alright. And what is the coefficient? Coefficient is 2. So basically we are just reading this first term. Okay. Next, P2 is equals to H2 of link. So basically after we have considered the first term, how do we implement the addition? We compare it with each term in the second polynomial. So that is what is happening here. P2 is equals to H2 of link. So this is the first term. P2 is equals to H2 of link. And we create another while loop. So we know why we are using while loops, because we are doing a traversal. So we are first traversing the P1 at an outer level, and inside for each term of polynomial 1, we are traversing the whole of polynomial 2 or the complete polynomial 2. That is why you see a while loop inside the while loop. While P2 of H2, P2 is not equals to H2. So you would consider this and go through the whole P2 polynomial. So every time you consider a node, you consider a term, you do the same. X2 is equals to P2 of x exponent, P2 of y exponent, P2 of z exponent, coefficient will be P2 of coefficient. So I hope all this is making a sense and readers are able to follow and correlate. So as I was saying, while I explained the logic, you can add two terms only if the coefficients match. So we will do that match here using the simple if construct. If x1 is equals to x2 and so and to ampersand make is what you have to use to make sure that all the three conditions satisfy. X1 is equals to x2, y1 is equals to y2, z1 is equals to z2. So if all the three exponents match, what does that mean? They are like terms. So if as I said, if they are like terms, what we do is we add the coefficient. Coefficient result is equals to coefficient 1 plus coefficient 2. And now that we have considered this first term, so as I said, considered is for this first polynomial. So now that we have considered it, we will make the considered as 1, and wherever we have found a like term, so this is a like term. So all the like terms are also have to be flagged as 1, or so this flag is nothing but like a consider variable or consider value, but we have created inside the node itself. So P2 of flag is equals to 1. Anyway, the logic is all the same. When we have considered for the first term in P1 and you are doing addition, and once you find a like term, you make that like term as 1 so that you are not printing it again. So that is the logic. Okay, and if you add two coefficient, suppose if the value of this P2 was -2, 2 minus 2 will be 0. So when the coefficient 0, the whole term may not be written, because 0 and anything is 0 going back to school. So that is what this condition is doing. If coefficient of result is not equals to 0, if the addition is not equals to 0, only then we will want to attach it to the result node or the H3 node. I hope it is all making perfect sense and making the understanding 100% clear. Only if the result of addition is not equals to 0, only then we add it to the header node of the result, or what we call as result linked list. So how do we add a node to the result linked list? By calling the function attach. We already understood how attach function works. H3 is equal to attach of. So since x1 and x2, y1 and y2, z1 and z2 are all the same, we can just take whatever we feel like, x1 or x2, y1 or y2, z1 or z2, and whatever is the result of addition, coefficient 1 plus 2, coefficient result will have to be passed as the coefficient to the result node. And again, as I explained earlier, we are referring the node, or we are referring the result node by this header node called H3. So we need to pass it in the parameter list. And what we have now done for each for each term in polynomial 1, we are comparing each term in polynomial 2. But how do we move forward in polynomial 2? By this logic. We are already very familiar with this logic of moving or traversing within a linked list. P2 is equals to P2 of link. Remember that it is all this is happening in the while loop which goes through the polynomial 2. Alright, so this while loop is now understood. But suppose let's say we didn't have a like term here, or for example, if when we are adding this polynomial x cube y cube z, the like term is not present in P2 because none of the terms have the have the exponent as 3, 3 and 1. So in that case, what are we supposed to do? We are simply supposed to write it in the result. This is what we do in simple maths as well. So how do we implement that in code? If considered is 0, that is if a like term hasn't been matched, so that will have a considered value as 0. If considered is equals to 0, we simply attach it to the result node, and our result node is h3. And once we have considered each node, if there is a like node, we have added. If like node is not present, we have simply printed. All that is done. Now how do we move forward in the P1? Using the logic for P1. P1 is equals to P1 of link. So this whole while loop is now understood. I hope if you have followed the explanation, you will definitely understand. If not, probably you could rewind and listen to this part again, because it is very easy to understand and interesting as well. So we have done the first part. What is the first part? Considering each term in the polynomial 1. So each term in polynomial 1 would be compared with each term in polynomial 2. If a like node is present, we will add it. If like term is not present, we will print it. But by now we would have guessed, or you would have understood that even in polynomial 2, there would be some nodes, for example like this 3x, which doesn't have a like node in P1. So what do we have to do with those nodes? The same with simple maths. Whatever is present which is not being added to any other node will simply come to the result node as it is. So how do we implement that? We do it here. So we start from the we start from the P2, that is from the first node. Anyway, if as soon as we have considered it for addition, we will make the flag as 1. So if the flag is 0, so flag will be 0 in this case because it is not considered for addition. If P2 of flag is equals to 0, so I have added comments here. You may follow the same practice for your understanding as well as the examiner's understanding. Not already considered for addition. What do? We simply add the node, or we attach the node to the result polynomial. So that is what we do here. H3 is equals to attach of whatever is the node, we simply attach it to the result polynomial. If you are familiar with some concepts of mathematics, whatever comes at the end are called tailing values, or you could call it tail values. For example, there is 1.000, all the zeros are tailing zeros, and in this case I am calling it tailing terms because they come at the tail is at the back, so they are called tailing terms. This is again all optional. Adding comments is left to your choice. So how do we move forward in the while loop? So we move forward in the while loop using this logic. P2 is equals to P2 of link. And what have we done now? We have considered each term in P1, did the addition. If like term is not present, we have printed as it is. In P2, since it is already added, whichever term is not added yet, that will come to the result directly. So we have done everything. We will just have to return the pointer to the result node. So we will just return H3. By this, you have understood completely the logic behind polyadd function. Moving on, we just have the main function, which is very simple because it is just creating a menu and running the program. So void main node head. So head is for this. So in this program there are two parts. One part is evaluation, other part is addition. So for evaluation part, we are creating this variable called head, and for this addition, we are calling we are creating three variables called h1, h2, h3. h1 for P1, h2 for P2, h3 for result. So we create choice for the menu, and initially when we are creating the circular linked list, we are calling the create function on each of these header nodes, head h1, h2, h3. And how do we make them linked list, or how do we make them circular linked list? By so this is what I explained in the beginning of the video. They are called circular linked list because the link is made to point to itself. So h1 of link is made to point to itself, h1. Head of link is head itself. h2 of link is h2 itself. h3 of link is h3 itself. I hope all of this is making sense because explanation is already done. We are now left with the menu itself. So how do we create an infinite loop? While of 1, and we give the message of the options, evaluation, addition and exit, and enter your choice, whatever is the choice. Based on the choice we run the appropriate case. So for case 1 we are doing polynomial evaluation. So first you will read the polynomial or ask the user to enter the polynomial. After it is entered, we display it just to validate what is being entered is considered, and after it is displayed we evaluate. I already explained what evaluation means, and end of case 1 we break. Case 2 is addition. So in addition we need two polynomials, poly1 and poly2. So we call the read poly function for h1, read poly function for h2, and we display it each time to again validate it. After we have accepted the input for p1 and p2, we call the function called polyadd, which does the addition for us, and whatever is the result of the polynomial, that is h3, will be printed using the display function, and we are breaking out of the case 2 using the break statement. Case 3 is for exiting the execution and exiting the program itself. So we have now understood the main function as well. So main function was actually simple because it is nothing but just creating a menu and just calling the appropriate functions. So I recommend you to follow the explanation, understand the logic, then write the program, then type the program accordingly. If at all any errors, debug it and then jump to execution. So let us now jump to execution to see if the program is doing the expected thing. So this is the environment where we run the program. This is the terminal or the command line interface where we execute C programs. So why I am comparing it with the image here, so that I enter the same values and you could appreciate whatever is done mathematically on paper is happening in the program as well. So one important note, please pay attention here. While executing C programs, we know that we use GCC and whatever is the program name. So what was the program name? Program name was P9. So we type capital P 9 dot C. This is all we need to do for any C program. But the only difference in this program is, or in any program which has this math.h header file, you will need to add something more here. I will first enter it here and display what the error message we get. So there we go. So it says undefined reference to POW. What is POW? POW is a power function, and power function is there in the header file math.h. So if you don't add something to this command or this execution command, you will see this error. So it is very important for you to add this command called -lm. So this is again it is a requirement of the GCC compiler. Wherever you are having the math.h header file, you could add -lm to the execution command. So after you enter -lm, if you click enter, you would see no errors. That means the program is successfully compiled. How do we execute or run the output of a program? Using this command .a.out. Click enter. We enter the menu. What does the menu offer? It offers three choices: evaluation, addition and exit. We first want to do the evaluation, so let our choice be 1. So it displays polynomial evaluation. Enter the number of terms in the polynomial. So this is again taken from the question. If a different polynomial is written on the board and ask you to, or you are asked to evaluate a different polynomial, you will write it down in your writer paper and enter in the output screen carefully. So how many terms are there? We have 1, 2, 3, 4 and 5 terms. So number of terms would be 5. Enter the first term. So don't don't really bother that it had to be ST here. This is just for our understanding. So I have just used TH for all the numbers, even though it had to be first, second, third and so forth. So you will just see TH for everything. On the first term, first we have to enter the coefficient 6. So all you have to do is just enter the value and just type space, or you could use tab or even enter as well, but for for cleanliness we will just use a single space. So coefficient is 6, x exponent is 2, y exponent is 2 again, z exponent is 1. So this is how you enter the term. After you after you enter all the values, you click enter. It waits for the second term. So what is the second term? So here is where you have to consider this sign of the coefficient. So minus 4 is the coefficient. So enter minus 4 as the coefficient, and x exponent will be, so x is not present here. If it is not present, we know that the coefficient of x is 0. So it is important for us to enter here, because on paper we know it is 0, that is why we have written, but for a C program to understand it, we will have to enter x exponent as 0, y exponent is 1, and z exponent is 5. Moving forward, we have the third term. Third term will have coefficient as 3, x exponent is 3, y exponent is 1, z exponent is also 1. Fourth term, coefficient is 2, x exponent is 1, y exponent is 5, z exponent is 1, 1, 5, 1. So be careful while you are entering the values, because all the evaluation depends on what you enter here. And then we are left with the last term, that is the fifth term. Coefficient will be minus 2, x exponent will be 1, y exponent will be 1, and z exponent will be 3. So we have entered the polynomial. Click enter now. So it just displays. So this is what I was saying, how it is displayed on the output screen. 6x, upper arrow indicates the power. So 6x square, y square, z. So a plus is there by default. So as I said, a plus into minus is minus, so it doesn't affect the value of the polynomial anyway. So plus is like a separator. So plus minus 4, x power 0, y power 1, z power 5, and you could verify reading it from the image here. So let us not waste time reading the whole polynomial. So what we are next interested to do is enter the value of x, y, z. What is the value of x, y, z? It is 1, 1, 1, for simple reasons, because we have already done the calculation on paper. So if we enter 1, 1, 1, the expected output should be 5. So let us click enter. There we go. We have the evaluation of result as 5. So we have successfully executed evaluation part. Now let us jump to addition part. For addition, your choice should be 2. So enter the first polynomial. So it is all just the same. So first enter the number of terms in polynomial 1. How many terms? 1, 2, and 3. So it is 3 terms. Let me enter the terms real quick. Just pay attention to what is there here, and you will identify why I am entering a particular number. 2, 1, 1, 2. Enter. 5, 3, 3, 1. Enter. 3, 1, 1, 1. So I have entered 3 terms. So it is being displayed here for your verification. Next, let us move to polynomial 2. In polynomial 2, we have 1, 2, and 3. So 3 terms. Let me enter those terms real quick. 3, 1, 1, 2. That is here. Enter. Next term is x, y, z. If the coefficient is nothing, that means it is 1. Coefficient is 1. X, y, and z will take values 1, 1, 1 each. Third term, the coefficient is 3. X exponent is 1. If y and z is not there, that means the exponent values are 0 and 0. Be careful while you are entering, otherwise you would run into errors. So 3x, y, z, 3x is also entered. Now we have entered the 2 polynomials. If I just click enter, the 2 polynomials, that is polynomial 1 and polynomial 2, will be added, and the result polynomial will be displayed for us. So let us click enter and see the magic. There we go. So we have printed the second polynomial, and very neatly we are printing the addition result. So let us now just compare 5 x power 1, y power 1, z power 2, x power 1, y power 1, z power 2, 5 x cube, y cube, z, 5 x cube, y cube, z, 4 x, y, z, 4 x, y, z, 3 x power 1, y power 0, z power 0, that is nothing but 3x. So whatever we are able to do it on paper with the concepts of mathematics, we are able to implement the same concepts of mathematics in our C program and demonstrate the output as well. So the only remaining step is to click 3 and gracefully exit the program. So in this program, or in this video, we have understood the concept of singly circular linked list. We have understood its concepts. We have understood the program. and we have also understood the output. So instead of considering this as a difficult program because of the way it is available, you could refer this video and refer the program used herein, and understand the program and execute it. That was all in this video. Thank you.